Today I am going to start with the next lecture for data communication network, that is KC 06363, and the topic of this lecture is transmission medium. So, the contents of the lecture is transmission medium and wireless transmissions. So, what is transmission medium basically? Transmission medium is whenever we are transmitting the information from the transmitter and the receiver, we have set up a connection between the transmitter and receiver that I have talked about in my previous lectures also. So, those connections that are established between transmitter and receiver, that can be a wired connection or that may be a wireless connection. In wired connection, a one to one wire has been set up between the transmitter and receiver. In case of wireless, there are different frequency ranges are used, like radio frequency, microwave frequency. In the microwave frequency range, if you are transmitting the information, so these are the or the satellite link. So, these are the cases related to the wireless communication, but in case of wired communication, twisted pair cable, coaxial cable, we will going to discuss in the lecture also. Wired connection is twisted pair cable, coaxial cable, optical fiber cable. These connections has to be set up as a part of the transmission medium in the case of wired connection. Now, this is the flow graph or flow chart you can see for the transmission medium. First one is guided or known as wired. What is guided? Whenever you are guiding the electromagnetic spectrum or the electromagnetic wave to be transmitted for the transmission purpose, means you are guiding it through the wired connection that has been set up between the transmitter and receiver. So, the guiding has been made between the transmitter and receiver. So, that is known as the guided propagation, you can say guided wave propagation. Next is the unguided wave propagation or the wireless. What is unguided? Unguided means you are not guiding it, it is a kind of broadcasting, means you are just transmitting the information. There is no surety that whether the signal will be received at the receiver side or not, or whatever way it is possible. So, that is the case for unguided situation. So, in case of guided medium, it is of different types. First one is the twisted pair cable, coaxial cable and fiber optic cable. So, in case of the twisted pair cable, two wires are twisted together for the transmission purpose. In the coaxial cable, a different kind of concept will be used. I am going to show you with the diagram. Which is having the coaxial cable, different coverings are there. Coaxial cable, simple copper wire, then above it there will be a plastic coating will be there, then braided coating will be there, metal, so that it will be safe. Then fiber optic cable, it consists of a core and cladding concept. In case of this unguided, there is a free space. Now, free space, what why it is written, it is dependent on different types of frequency bands that we can use, like we can use radio frequency, we can use microwave frequency range. So, this is how the frequency ranges will be used for free space transmission. Now, this is the twisted pair cable. A twisted pair cable consists of two conductors, normally copper, each with its own plastic insulation twisted together. So, two copper wires having a plastic coating or the plastic covering which are twisted together. So, this is the simplest kind of construction of a particular cable which is used, and these are used in earlier days for the transmission of voice signals only, means for transmission of voice signals or for transmission of electric signal of very low strength. That is why it will going to withhold that particular strength of signal. So, that is why this twisted pair cable is used. One of the wires is used to carry the signals to receiver and the other wire is used as a ground reference. So, the receiver uses the difference between the two. So, one is the positive side and one is the negative, you can say, or the ground purpose it is used. In addition to the signal sent by the sender on one of the wire, interference and crosstalk may affect both the wire and create the unwanted signal. So, this is some explanation related to this twisted pair cable. Let me show you the another diagram, that is the coaxial cable that I was talking about. This is the inner conductor that is made up of copper. It is made up of copper mostly, but you can use another conductor also, but copper is generally used. Then it is covered with an insulator, basically a plastic coating will be used, plastic coating or plastic cover. Then a outer conductor will be there, that will be a braided conductor. It is made up of metal only, braided, you can see due to its mesh structure. Then again a plastic coating will be used, and then a plastic cover, final cover will be there. Insulator can be used of any type of material. So, this is the basic construction of the coaxial cable, how the data will be transmitted. If you are going to compare the twisted pair cable with the coaxial cable, then you can say that it will be used for a longer distance, it will be going to withhold the signal of large value, it can be transferred over a longer distance, its strength is quite well as compared to the twisted pair cable. So, that is why this coaxial cable is used. You have different options of the cable like twisted pair cable, coaxial, and then optical fiber cable, depending on the application, depending on the strength, depending on the distance, you can choose any of the cable. Now, next is the fiber optic cable. Fiber optic cable revolves around two things, that is core and cladding. These two terms are important in case of fiber optic cable. The sender will going to generate the signal, it is in the form of light, it will going to travel through this core, and here the total internal reflection will take place, that is TIR. It is based on the total internal reflection, and it will going to be received at the receiver side. This fiber optic cable, you can say the diameter of this fiber optic cable is comparable to the one strand of your hair. It is used to withhold a signal of higher quality, means higher strength, it will going to withhold. In most of the application this fiber optic cable is used, but what is the disadvantage? There are some disadvantages are also there related to this fiber optic cable. First disadvantage, its maintenance. Its maintenance cost is quite high. You require specified engineers. If any fiber optic cable is break between 10 kilometers of distance or something, then you have to identify that what is the problem. Engineers are required. So, the maintenance cost is quite high. Secondly, the cutting of this fiber optic cable, that is known as splicing, is done at a it has to be done at a with great accuracy. So, that requires the main consideration for the purpose of this fiber optic cable. So, like cutting off the fiber optic cable means, if you want to join two optical fiber cables together, then a particular kind of cutting has to be involved for the purpose of transmission purpose. So, that is the case for fiber optic cable. So, there are two things involved, that is core, cladding, and it is based on the total internal reflection. Now, next is propagation modes. There are different types of propagation modes are involved. First is the multi mode and another one is the single mode. Propagation modes means how the wave will going to travel in a optical fiber cable or the cable which has been set up between the transmitter and receiver. So, in that case different modes are involved, two types of modes are there, multi mode and single mode. It is step index, multi mode is again divided into step index and graded index. I am going to show the diagram in detail. What is step index, what is graded index, and what is single mode of operation. Like see this diagram, this is multi-mode step index, this is multi-mode graded index, and this is single mode. First I will show you what is single mode. Single mode, you can see that whatever shape of the signal will be there at the transmitter side, it will going to change its shape because of the distance it will going to travel, because of the noise that will be going to affect the quality of the signal, but there is no crosstalk you can say, or there is no problem, because only single mode of transmission propagation mode will be supported by this. But in case of this multi-mode graded index, you can see that the loss of information will take place. Dispersion of pulses is there, definitely there is dispersion of pulses that will cause loss of information, and you can see that one wave is transmitting like a single mode and another is overlapping over it. Now, next is multi-mode step index. In case of multi-mode step index, you can see that the sharp edge transmission will take place, rotor internal reflection will be quite well, and there is no problem of dispersion. Dispersion of pulses will be there, but the information will be you can also see that the energy or the strength of the signal will be reduced, and also it will not going to it is not affected with the noise. So, that is the case for multi-mode step index. So, these are the different propagation modes are there which are used for the transmission purpose. So, till now let me summarize once again what we have seen. We have seen transmission mediums. In case of this transmission medium, we have seen guided medium and unguided medium. In case of guided medium, we have seen till now twisted pair cable where two wires are twisted together. This is how these are twisted together, these are two wires used for carrying the voice signals, cannot be used for long distance communication. Strength of the signal which has to be transferred over that twisted pair cable is not good. It cannot be used for high data rate, means nowadays you know that all things are there on internet only, all is based on the data rate. So, it will not going to support the high data rate. Then comes the coaxial cable, where the structure is there, where a single conductor of copper will be there, which is been rolled with a insulator, then a braided conductor will be there, then again a insulator, and then final a plastic covering will be there. So, that can be used over a longer distance as compared to the coaxial cable. Then next we have seen the optical fiber cable or fiber optic cable, which consists of the main consideration, that is core cladding concept, and it is based on the total internal reflection. Then we have seen the propagation modes. There different types of propagation modes are there, like single mode, where the dispersion of pulse will not take place to a quite level, only the shape of the pulse will change due to the effect of noise, means the information will be contained in that particular signal. Then multi-mode graded index, the strength of the signal will be maintained, but the dispersion of pulses is there and the crosstalk will take place. In case of this step index, the strength of the signal will be reduced. So, this is about the propagation modes. Now, next we will see wireless transmission. Wireless transmission is broadcasting. There is no point to point connection between the transmitter and receiver. It is basically dependent on the duration or the frequency range in which this radio wave is, in which the particular information will be transmitted. Like first one is the radio wave frequency range will be used. Next one is the microwave frequency range, and other is the infrared frequency range. So, in case of this radio wave frequency range, whenever the communication will take place through this wireless communication, wireless transmission, but the data will be transferred in case of in the form of this in the range of radio wave, then it is known as radio wave propagation. Whenever the frequency is greater than 1 gigahertz, then it is known as microwave frequency range, and this is related to the infrared case. Next, we will move to the type of antenna that will be used for any kind of this broadcasting, because in case of wired and wireless both, antenna will be used, because the first device that will be going to receive the signal, like this is the transmitter, this is the antenna associated with the transmitter, this is the receiver, this is the antenna associated with the receiver, and this is the channel. It may be wired channel, it may be wireless channel. So, first antenna that we will see is the omnidirectional antenna. What is omnidirectional antenna? As you can see that the radiation pattern of this particular antenna is forming a sphere, means it will going to radiate equal amount of energy in all the directions. Some facts are associated with this omnidirectional antenna, like in whichever direction you are going to see the strength of the signal, it will be of equal strength, it will be of equal weightage. The gain of the antenna of this omnidirectional, the gain of this omnidirectional antenna is equals to 1. You can find out the diversity using this gain also. There are some formulas related to the antenna, that is diversity, you can find directivity, you can find out in which direction the strength of the signal is large, you can find out the gain of the omnidirectional antenna is 1. It is always described in that unit, that is decibel. So, this is about the omnidirectional antenna. Now, next is the unidirectional antenna. What is unidirectional antenna? Unidirectional antennas of two types. This is dish antenna and horn antenna. What is dish antenna? Dish antenna you are very familiar with. In case of this dish antenna, you are having Airtel or Tata Sky in at your home. They all are having dish antennas. They are using. So, this is the diagram of the dish antenna. This is the focus point, and whatever energy it will going to signal, it will going to receive, it will going to focus on a it will going to center or transmit over a single focus. So, that is the case for dish antenna. Next is the horn antenna. This is having the shape of horn. It is connected through a waveguide, and the direction of the signal will be shown over here. So, this is how the unidirectional antenna will work. So, till now we have discussed two types of antenna, omnidirectional antenna which is having gain is equals to 1. Then we have seen unidirectional antenna which is of two types, it is dish antenna, horn antenna. Dish antenna is going to focus the energy on a single focal point. Then horn antenna is having the shape of this horn, and it will be connected through a waveguide, and the direction of the pulse is shown over here. So, what we have seen, let me just remind you once again. This is the structure of this coaxial cable, where this is the plastic covering is there, then insulator, two insulators are used, and this is the braided index which is been in the form of metal, outer conductor, and this is the inner conductor. So, this is the constructional view of this coaxial cable. Then next comes the fiber optic cable, which is made up of this core and cladding, and this is based on the total internal reflection. The disadvantage of this fiber optic cable is the maintenance, and the if any kind of problem will be there between the is there in the constructional view, then the cutting or the splicing of that particular optical fiber cable is very costly, and it needs special attention for this purpose. Next is next we have seen the propagation modes, that is two types of propagation modes are there, that is the multi mode and the single mode. In case of single mode, only single wave will be transmitted, and there is no dispersion of the pulses will take place, whereas in case of this multi mode, more than one modes will going to be transmitted, and it is based on the step index and graded index. like this is the single mode diagram. You can see that no dispersion or the crosstalk will take place, it will going to be but only the shape of this pulse will change. Then the multi-mode graded index will be there, which is been based on the dispersion of pulses will be there, and because the shape of the pulse will going to change, and also the crosstalk will be there. Then next we have seen the multi-mode step index, where more than one pulses will again going to transmit, but the strength of the signal will be reduced. So, this is the propagation mode. Next we have seen the wireless transmission. I have told you that different types of frequency ranges are used, like radio wave frequency range, microwave frequency range, and infrared frequency range. Radio wave is related to the in super heterodyne receiver or different types of receiver, the radio wave frequency range is used. In case of microwave devices greater than 1 gigahertz of frequency range, this microwave device will be used. Another is the infrared frequency range of operation, which is also used for the wireless transmission. Now, next we have seen different types of antennas that are used that are part of this communication. Omnidirectional antennas or the directional antennas. Directional antennas are also known as the unidirectional antennas, because it will going to concentrate energy in only one direction, its directivity is quite high. Omnidirectional antenna, the gain is 1, because it will going to transmit the energy equally in all the directions. Its gain is 1, and it is being expressed in terms of decibels. This is the unidirectional antenna that we have seen. This is the dish antenna. Dish antenna will going to focus the energy on a single focal point, and then horn antenna. So, this is all about the antennas, propagation modes, and transmission medium that we have seen, and these are the references that you can go through. Thank you.